Hello everyone, welcome to Vyas Edification Kota. In this session, we are going to discuss all NCERT and exercise solutions of class 12 chapter number 8 electromagnetic waves. Clear? So, in this session, you will find detailed video solution of each and every question, as well as you will find some key concept behind that question also. Clear? So, now we are going to start. Concentrate on a screen. Now dear student, we are going to discuss this question, and this question is asked, actually this question is 8 point number 1, clear. In this question it is given to you, figure shows a capacitor made of two circular plate, each of radius 12 centimeter, clear. So we can see, if we talk about radius, so radius is given to you r. This is equal to 12 centimeter. We can convert into meter. So 12 into 10 to the power minus 2 meter. Clear to everyone? Yes. And it is separated by a distance 5 mm. So we can say this separation distance is given to you. This is 5 mm. Clear? So from here you can say, let's suppose this is D and this value is 5 mm and this is equal to 5 into 10 to the power minus 3 meter. Clear to everyone? Yes. Now it is also given the capacitor is being charged by an external source, and that external source is not shown in a figure. The charge current, or we can say the charging current, is constant, and this is equal to 0.15. Now we can say outside this capacitor whatever we have current, this current is known as conduction current, and outside this capacitor displacement current is 0. And what about total current? So we can say inside, or we can say between the parallel plate capacitor we have displacement current, and in this region conduction current is 0. But we know this current is constant, IC equal to ID. So this value is given to you, I equal to 0.15 ampere. So from here we can write like this, value of I, this is 0.15 ampere. Clear to everyone? Now what is our objective in this question? Our objective in this question is to calculate capacitance and the rate of change of potential difference between plates. Clear? So now we know, we can see, yes, we know value of capacitance. Now we know that if we have parallel plate capacitor and between these parallel plates if air is included, at the time we can say capacitance value is given by epsilon naught A by D. Clear? So from here we can say this is given by epsilon naught A by D. Clear? Now what is value of epsilon naught? This is equal to 8.85 into 10 to the power minus 12 multiply. What about area? Radius of circular plate is given, and so we can say this is pi into r square, means 12 into 10 to the power minus 2 whole square divided by, we can say D. D means we can say this is distance between parallel plate capacitor. So this is equal to 5 multiply 10 to the power minus 3 meter. Clear? So from here we can say this is equal to 8.85 into pi multiply, we can say 144 into 10 to the power minus 4. 8.85 into pi multiply 144 into 10 to the power minus 4 into 10 to the power minus 12, and it is divided by, we can say 5 into 10 to the power minus 3. Clear to everyone? 8.85 multiply pi multiply 144 into 10 to the power minus 4 and this one. From here you can say this one is cancelled out, this is 10 to the power minus 1. Clear? So we can say value of capacitance C, this is given by 8.85 multiply pi, clear, we can say 144 into 10 to the power minus 13, and it is divided by 5. Clear? So if you find here, if you solve it, you can say this is 1, we have 7, and again we have 7, 1.77 pi into 144 into 10 to the power minus 3. So from here you can say, let's suppose if you assume this pi is near about 3. Clear? So we can write like this, this is 21, we have 2, this is 23, we have 2, so 3 multiply 2, this is 5.31. Clear? 5.31 multiply 144 into 10 to the power minus 13. Clear? And this value we have in farad. Clear? So now if you multiply 5.31 with 144, so near about, if we take this is 5.5, so 5.5 means we can say this is 11, this is 11 divided by 2, near about. clear. So 11 divided by 2 multiply 144 into 10 to the power minus 13, clear. So from here we can say value of C, this is given, this is 4, we have 4, 8, 4, 1, 5, 8, 4 divided by 2 into 10 to the power minus 13, clear. So value of C, this is given 7, we have 1, we have 9, 2, clear. 792 into 10 to the power minus 13, clear. So from here you can see this C is near about, this is 80 into 10 to the power minus 12, and because this is capacitance, capacitance value we find in farad, clear. So C value is, we are getting, this is 80 picofarad, clear. So this is what, this is value of capacitance of this capacitor, clear. Now listen carefully. In this question we have one more part of A, that what is value of rate of change of potential difference between plate, clear. So from here we can see if we want to find rate of potential difference, just a minute, I am writing this value in this side because this will be useful for us for next parts, clear. Yes, so from here we can say actually we know Q is equal to what, CV, clear. So if we differentiate this charge Q with respect to time t, we can say this is given by C dV by dt, clear. So from here can we calculate value of dV by dt? Yes. So dV by dt, this is given by dQ by dt, dQ by dt is equal to what? We can say this is rate of charge. So we can say this is equal to what? Current divided by capacitance, clear. Value of current is given in this question 0.15 divided by value of capacitance, this is equal to 80 multiply 10 to the power minus 12, clear. So from here you can see this is equal to 15 by 100 into 80 into 10 to the power 12, clear. 1, 2, 3, we can say this is 10 to the power 9, clear. So from here we can write like this, this is given by this is 1 point, now we have 7, so we can say 1.8 into 10 to the power 9, and this is volt per, we can say second, clear. So this is answer of rate of change of potential difference between plates, clear to everyone? Yes. Now we are going to discuss part number B, clear. So now concentrate, part number B. Clear. So actually I am writing here value of C, this is 80 picofarad, clear. Now part number B is given to you, obtain the displacement current across the plates, clear. So this is very easy, we can say displacement current is equal to conduction current, and this value we have equal to 0.15 ampere, clear. Outside this parallel plate capacitor we have only conduction current, and between this parallel plate capacitor we have displacement current, clear. But if we talk about magnitude, magnitude is same, and we can say IC equal to ID, this is equal to 0.15 ampere, clear. So we can say A and B completed. Now we are going to discuss part number C. In part number C it is given each Kirchhoff's first rule, or we can say junction law, it is valid at each plate of the capacitor explained. Now listen carefully. Now you can see if we talk about this parallel plate capacitor, now incoming current is equal to what? This is conduction current, clear, and here we are having displacement current 0, and what is outgoing current? Outgoing current we can say this is equal to ID, and ID is having same magnitude as IC. It means we can say incoming current is equal to outgoing current for this parallel plate, clear, or we can say IC equal to ID. It means we can say yes, Kirchhoff junction rule is valid for the each parallel plate capacitor, clear, or each parallel plate, clear. So yes, definitely, so I can say yes, we can apply Kirchhoff junction rule. Kirchhoff junction rule actually based on a conservation of charges. Now you can see here the incoming current, it is equal to outgoing current, so Kirchhoff junction law is valid, clear. So this is all about this question, clear. Now dear student, we are going to discuss question number 8.2. In this question it is given to you a parallel plate capacitor made of circular plate each of radius 6 centimeter. Clear? So we can write like this: radius of this circular plate is given 6 centimeter. This is equal to 6 into 10 to the power minus 2 meter. Clear to everyone? It has a capacitance of 100 picofarad. So we can write like this: capacitance 100 picofarad, or we can say 100 multiply 10 to the power minus 12 farad. Clear? The capacitance, the capacitor is connected to 230 volt AC supply. It means we can say VRMS, it is given to you 230 volt and having angular frequency of 300 radian per second. Clear? So we can say omega, this is equal to 300 radian per second. Clear? Omega is given to you 300 radian per second. This is given. Now our first objective in this question is to calculate value of RMS value of conduction current. Clear? So how can we calculate RMS value? So first we can write like this: IRMS equal to VRMS divide by, now listen carefully, actually this capacitor we have. So for the capacitor we always write capacitive reactance. Capacitive reactance is indicated by Xc. Clear? So we can say this is equal to VRMS divide by 1 upon we can say this is omega C. Clear? So from here you can write like this: omega C multiply VRMS. Clear? So from here you can say IRMS is given by value of omega. Value of omega we have 300 radian per second. So this is 300 radian per second. What about C? C value is given 100 into 10 to the power minus 12, or we can say 10 to the power minus 10 farad. Clear? So 10 to the power minus 10 farad multiply, we can say VRMS. VRMS is given 230 volt. Clear? So this is multiplied with 230. Clear? So from here you can say 3 into 10 to the power minus 8 multiply 230. Clear? So we can say this is equal to 69 into 10 to the power minus 7 ampere. Clear? Or we can write like this: this is equal to 6.9 into 10 to the power minus 6 ampere, and this is 6.9 micro ampere. Clear to everyone? 6.9 micro ampere, this is value of IRMS. Clear? So this is all about part number A. In part number B, it is given is the conduction current is equal to displacement current. Yes, definitely I can say that conduction current is equal to displacement current. Displacement current is equal to conduction current. How can we say? Actually there is one formula for displacement current. Displacement current, this is equal to epsilon naught d phi e by dt. Clear? So from here we can write like this: this is equal to epsilon naught d by dt, and what about phi e? Phi e we can say this is equal to b dot a. Now listen carefully. Now let's suppose here we have positive charge at a certain instant of time, here we have negative charge. So definitely electric field in this direction, and area vector is also perpendicular to this circular surface. Clear? So we can say both are in the same direction. So directly we can say angle between them is 0. Now from here we can take this area outside d by dt, and this is equal to b. Clear? Yes or no? Yes. So from here actually this is electric field. Okay, just a minute. From here you can say this is value E. Clear? Because here we have electric field, not magnetic field. So this is E and this is also E. Clear? Now we know for a parallel plate capacitor, we can say value of E between parallel plate between this space is given by sigma upon epsilon naught, and we are assuming initially that we are assuming there is no any dielectric medium present between these parallel plates. Clear? So from here you can say E value we can write like this: this is Q upon A epsilon naught. Clear? So now I am placing this value here. So this is equal to what? Epsilon naught A d by dt. Clear? This is equal to Q upon A epsilon naught. Clear? So from here you can write like this: epsilon naught A multiply, we are taking this epsilon naught A outside, and this is equal to dq by dt. Clear? So from here we can say this one and this one cancelled out, and this is equal to what? dq by dt. Clear? So from here we can say if this is displacement current, dq by dt is actually rate of flow of electric charges, and this is equal to what? Conduction current. Clear? So from here you can see that we can directly say that conduction current is equal to displacement current. Clear? Always keep in mind, outside parallel plate capacitor we have only conduction current and displacement current is 0. So to maintain consistency, we actually find that between parallel plate capacitor we have displacement current and conduction current is 0. Clear? And magnitude wise both are same. Clear? Now listen. Now if we talk about part number C. In part number C it is given, yes, determine the amplitude of B, means magnetic field at a point 3 centimeter from the axis between plates. Clear? Now you can say, let's suppose we are talking about, because AC source is connected here. So at an instant, let's suppose here we have positive, this is negative, and let's suppose this is axis between this space or axis of these two circular plate. Let's suppose I am taking one point. Let's suppose we are taking a point P where we have to find magnetic field, and it is given this is at a distance 3 centimeter. Clear? So for that one, first you will draw here an Amperian loop. Clear? So first we draw an Amperian loop. So I am just drawing Amperian loop like this. This is Amperian loop. Clear? Now, so can we apply here Ampere circuital law? Yes, we can apply Ampere circuital law. So how can we write here? We can write like this. If we apply Ampere circuital law, this is given by integral of B dot dl. This should be equal to mu naught. We can write here this is I enclosed. Clear? Now our next objective is to calculate I enclosed. How we will find? Listen. We can say actually radius of this surface is given, that is r. So from here we can say whenever we have area pi r square, current that is flowing, this is displacement current id. Clear? Whenever we are having, let's suppose this is 3 centimeter is equal to small r. So we are having area pi r square. So when we have area pi r square, what is value of current this is flowing? So we can say this is given by id. Clear? Id pi small r square divided by pi capital R square. Clear? From here we can say pi and pi, this is cancelled out. So this is equal to what? id and multiply r square divided by capital R square. Clear? So this is value of current that is going through this Amperian loop. Clear? Now you can say, sir, how can this magnetic field is produced here? So you can imagine actually there is no any physical conducting wire is present here, but we are saying because we are assuming this concept that displacement current is flowing. So if I put my thumb in this direction, this curling finger represent direction of magnetic field. Now you can say, sir, how we know that here we have a displacement current? So actually we practically observe, let's suppose if we are bringing any magnetic compass between these parallel plates. So at the time that magnetic needle of that compass is actually deflecting. So when this is deflecting, so magnetic needle deflect only when there is a magnetic field is to be there. Clear? So now we can say, from there we can say if there is a magnetic field between parallel plate capacitor, it means there should be any current, and actually that current is not is visible, or there is no any conducting wire. That's why we are just saying this is displacement current. Clear? So from here you can say that current that is flowing through this Amperian loop, this is given by id r square divided by capital R square. Clear? So now we can write like this, B dot dl. First listen carefully, B dot dl. So if I am taking here, this is a very small element, area vector in this direction, B is also in the same direction. Clear? So from here we can write like this, B, clear, integral, cyclic integral of dl, this is equal to mu naught. We can say this is id small r square divided by capital R square. Clear? From here we can say dl. Now if I write dl, then we can say this is equal to what? 2 pi r. Clear? Because this is line integral, so we can say this is 2 pi r, and this is given by mu naught id, this is r square divided by capital R square. So from here we can say r and r, this is cancelled out. Clear? So value of B, this is given by mu naught ID divided by 2 pi capital R square multiplied with R. Clear? So this is an expression of magnetic field. Now we can find this value. So now I am placing this value, we are actually putting all the values like mu naught ID, 2 pi R square and small r. Clear? So now concentrate. Yes. So from here we can say this value is given to you B. B is given by I can say mu naught ID divided by 2 pi R square, and we can say this is smaller. So student, now this formula we have B equal to mu naught ID upon 2 pi R square multiply R. Now I can put all values. Mu naught, this is given by 4 pi into 10 to the power minus 7 into ID. Now what is value of ID? ID is actually maximum current between parallel plate capacitor, and when conduction current is equal to displacement current, then we can say this ID corresponds to maximum value of current. So maximum value of current means we can say this is equal to under root 2 times of IRMS. Clear? Multiplied with R divided by we can say 2 pi into R square. Capital R we have 6 centimeter. So 6 into 6 into 10 to the power minus 4. Clear? From here we can say this is equal to what? 2. So 2 into 10 to the power minus 7. Clear? Under root 2. IRMS. IRMS is given to you. This is 6.9 micro ampere. So this is 10 to the power minus 6. Multiply. What about R? R is 3 centimeter. 3 into 10 to the power minus 2. Clear? Divided by. We can say divided by. Just a minute. So from here we can say it is divided by equal to 6 into 6 into 10 to the power minus 4. Clear? Now we can say this one and this one cancel out, 10 to the power minus 2, this is 10 to the power minus 4. Clear? From here we can say this is 3, and from here we can say this is 2.3. Clear? 2.3. So from here we can say value of B. Value of B we have, this is 2.3 into 10 to the power 2.3 into 3 into 10 to the power minus 4. 2.3 into 3 into 10 to the power minus 4 into we can say 10 to the power minus 7. Clear? Multiply under root 2. Clear to everyone? 2.3 multiply 3, 10 to the power minus 4 under root 2, 10 to the power minus 7. Clear? 2.3, 3, I can say 10 to the power minus 4, 10 to the power minus 7 under root 2. Clear? Now we can say it is divided by 6 only. Clear? From here you can say this is equal to what? 2. So B is given by 2.3 under root 2 divided by 2 into 10 to the power minus 11 Tesla. Clear? Now from here you can see we can write like this, 2.3 into 1.4 divided by 2 into 10 to the power minus 11 Tesla. So now if I multiply 2.3 with 1.4, we can say this is what? 42, we have 4, so 32. Clear? So it is divided by 2. Now we can say here this is 3.22. Clear? And it is multiplied with 10 to the power minus 11 Tesla. So from here we can say this is 1, and we have 6, and this is 1.60 into 10 to the power minus 11 Tesla. Clear? So this is value of magnetic field. So this is all about this question. Now dear student, we are going to discuss this question number 8.3, and in this question it is given to you what physical quantity is the same for X-ray of wavelength 10 to the power minus 10 meter, red light of wavelength 6800 angstrom, and radio waves of wavelength 500 meter. Clear? So dear student, we know if we talk about electromagnetic spectrum, so for electromagnetic spectrum, one quantity that remains same irrespective of their wavelength, that is speed of electromagnetic wave in vacuum. Clear? So I can say speed of electromagnetic wave in vacuum, this is given by 3 into 10 to the power 8 meter per second. Clear to everyone? So speed of electromagnetic wave in vacuum, this is given by 3 into 10 to the power 8 meter per second. Clear? So this quantity remains same irrespective of their wavelength. Clear? So this is all about this question. Now student, we are going to discuss question number 8.4, and in this question it is given to you a plane electromagnetic wave travels in vacuum along z direction. Clear? So let's suppose I am taking this as my z direction, this is z direction. Clear? This is what, let's suppose x direction, and this one is y direction. Clear? According to this question, a plane electromagnetic wave travels in vacuum along z direction. Clear? Now we know electromagnetic wave is produced by oscillating charge particle. Clear? And whenever we have oscillating charge particle, definitely we can say electric field and magnetic field is associated with it. Clear? So if we talk about electromagnetic spectrum, although the direction of propagation is z direction, but its electric field and magnetic field both are perpendicular to each other, as well as they are perpendicular to direction of propagation. Clear? So in this question it is given direction of EMW. This is direction of EMW, but what about electric and magnetic field? So I am showing here, just let's suppose this is electric field. This is an oscillation of electric field, but what about oscillation of we can see this is magnetic field. Clear? So magnetic field oscillation, this is given by, just a minute, this is given by like this. Clear? So from here you can see, if I draw here this diagram, actually this black curve represent oscillation of magnetic field. Clear? This magnetic field is oscillating in y direction. Clear? This is representing oscillation of magnetic field, and maximum value of magnetic field I am writing, this is B naught. Clear? If I am talking about this one, this is an oscillation of electric charge particle, and we can say it represent electric field. So electric field is actually oscillating in the direction of, we can say in the direction of x. Clear? So from here you can say, although direction of propagation of this electromagnetic wave in z direction, but magnetic field and electric field both are oscillating in x and y direction respectively. They are perpendicular to each other, as well as they are perpendicular to direction of propagation of wave. Clear? So one more question is given to you. If frequency of this wave is 30 megahertz, what is wavelength? Clear? So actually we know one relation, V is equal to f lambda. Clear? Because this electromagnetic wave is traveling in vacuum, so we can write like this, C equal to f lambda. Clear? Clear? C is what? This is speed of this electromagnetic wave. So from here we can find, our objective is to calculate wavelength. So this is C by f. Clear? What is value of C? This is 3 into 10 to the power 8. So 3 into 10 to the power 8 divided by, what about frequency? Clear? Frequency is given to you 30 megahertz. So 30 into 10 to the power 6. Clear? From here you can say this is 100. This one is cancelled out. So from here we can say this is 10 meter. Clear? So wavelength of this electromagnetic wave, this is given by 10 meter. Clear? So this is all about this question. Now student, we are going to discuss question number 8.5, and in this question it is given to you, a radio can tune into any station in the 7.5 megahertz to 12 megahertz band. What is the corresponding wavelength band? Clear? So now we can say, actually we know one relation, V is equal to f lambda. Clear? If I am talking about vacuum, so in the case of vacuum we can write like this, C is equal to f lambda. Clear? So from here we can say lambda is given by C by f. F is equal to what? This is frequency. Clear? So from here we can say this is given by 3 into 10 to the power 8 divided by frequency. Frequency is given to you 7.5 megahertz. Clear? Or we can say second frequency is given to you, this is equal to 3 into 10 to the power 8 divided by f2. f2 we have 12 into 10 to the power 6. Clear? So from here we can write like this, this is equal to 100. Clear? And we can say that is 4. Clear? This is equal to 100. Clear? We can say this is 1000 and this is 25. Clear? So from here we can say this is equal to 40 meter. clear, and this is equal to what, we can say this is 25 meter, clear. So if you are talking about frequency range 7.5 megahertz to 12 megahertz, at the time we can say corresponding wavelength range, it is given by 40 meter to 25 meter, clear. Directly you can observe if frequency increases, corresponding wavelength decreases, clear to everyone. So this is all about this question. Now dear student, we are going to discuss this question number 8.6. In this question it is given to you, a charged particle oscillates about its mean equilibrium position with the frequency of 10 to the power 9 Hz. What is the frequency of electromagnetic wave produced by oscillator? Now we know that oscillating charged particle produces electromagnetic wave, clear. So it means the frequency of oscillating charged particle is given 10 to the power we can say 9 Hz. It means we can say if there is a charge that is oscillating in nature, it means electromagnetic wave is also having same frequency, clear. So in this question you can say the frequency of the electromagnetic waves produced by the oscillator, this is equal to 10 to the power 9 Hertz, clear to everyone, 10 to the power 9 Hertz, clear. Now student, we are going to discuss this question number 8.7, clear. In this question it is given to you, the amplitude of the magnetic field part of a harmonic electromagnetic wave in vacuum is given to you B0, and B0 is equal to 510 nano Tesla, clear. So maximum value of magnetic field, this is given to you 510 nano Tesla, clear. Now what is the amplitude of electric field part of a wave, clear. So actually we know one relation between maximum value of electric field and magnetic field, this is C equal to E0 divided by B0. Our objective in this question is to calculate value of E0, this is given by C B0, clear. Value of C we have, this is 3 into 10 to the power 8 and multiply, what is B0? B0 is given 510 into 10 to the power minus 9 Tesla, clear. So from here we can say this is equal to what, 1530 into 10 to the power 8 into 10 to the power minus 9, clear. So from here we can write like this, this is we can say 153, and we can say this is Newton per Coulomb, because this is electric field. So electric field is given in the unit of Newton per Coulomb or volt per meter, clear. So correct answer we have 153 Newton per Coulomb, clear. Now we are going to discuss question number 8.8, and in this question it is given to you, suppose that the electric field amplitude of an electromagnetic wave is E0 equal to 120 Newton per Coulomb. So E0, this is given to you 120 Newton per Coulomb, clear, and that is frequency is given to you mu, this is equal to 50 megahertz, clear. This is equal to 50 into 10 to the power 6 Hertz, clear. Now we have to determine value of B0, clear, means maximum value of magnetic field. So from here we know actually one relation, this is C equal to E0 divided by B0, clear. So from here we can write B0, this is given by E0 divided by C, clear. Value of E0, it is given in this question 120 Newton per Coulomb, this is 3 into 10 to the power 8. So this is given by 40 multiply 10 to the power minus 8. So from here we can write like this, B0 value, B0 is equal to 4 into 10 to the power minus 7, and this is Tesla, clear. So maximum value of magnetic field, this is given 4 into 10 to the power minus 7 Tesla, clear. Now if we talk about our objective is to find omega, omega is equal to 2 pi into frequency, clear. We can write like this, 2 pi into 50 into 10 to the power 6, clear. So from here you can see this is equal to 100 pi into 10 to the power 6, clear. So from here you can write like this, pi into 10 to the power 8 or 3.14 into 10 to the power 8, and this is radian per second, clear. Third objective is to calculate value of k, but first we find lambda. Lambda is equal to what? This is given by c divided by frequency, clear. Value of c is given 3 into 10 to the power 8. What about frequency? Frequency is given to you 50 hertz, so 50 into 10 to the power 6. From here we can say this is 3, clear. So we can write like this, this is 100, clear, and we can say this is 2. So from here this is 6 meter, clear. Value of lambda we have 6 meter, fine. Now our objective is to calculate k. So k, it is given by, actually this is wave number, and this is given by 2 pi by lambda, clear. Now we can put here 2 pi by lambda, this is 6, so we can say this is 3, clear. Value of pi 3.14 divided by 3, clear. Value of we can say k, this is 3.14 divided by 3, and this is given by 1 point, clear, 0, and we can say that is 4, clear. So 1.04, and we can say this is equal to what? Radian per meter, clear. Yes or no? This is 2 pi by lambda and this is 1.04 radian per meter. Now second part, in this question we have find expression of E and B, clear. So we can write like this, just a minute. Our objective in this question is to calculate value of E, clear. So how can we write? We can write like this, value of E, this is given by E naught sine of kx minus omega t. Now we know electric field and magnetic field, which are oscillating in nature, always are having same phase, clear. Same phase means we can write like this, this is given by B equal to B naught sine of kx minus omega t. Now what we can do? We can put value of k here, we can put value of omega here, clear, and we know that maximum value of E naught we have electric field, this is 120, clear, and maximum value of B naught we also know, this is 4 into 10 to the power minus 7 Tesla. Now we can put all the values. So value of B naught we can put here, value of E naught we can put, clear, this one, clear, and k and omega value we can put, and we can find expression of electric field and magnetic field, clear. So this is all about this question. Now student, we are going to discuss question number 8.9, and in this question it is given to you the terminology of different parts of electromagnetic spectrum is given in the text. Use the formula E equal to h nu for energy of a quantum of radiation photon and obtain the photon energy in units of electron volt for different parts of electromagnetic spectrum, clear. In what way are the different scales of photon energy that you obtain related to sources of electromagnetic radiation, clear. Now listen carefully. Actually our objective in this question is to calculate E equal to h nu, clear. It is given by Hc by lambda, clear. This is the formula. Now we know for our different electromagnetic spectrum we have different frequency. So from here we can calculate value of h nu, and here you will find answer in joule, clear. But you can also calculate in electron volt also. So for that one you have to divide here with charge of an electron, and you will get now answer in electron volt, clear. So from here you can write like this, E equal to 6.6 into 10 to the power minus 34. This is Planck constant, and value of Planck constant is given by 6.634 into 10 to the power minus 34 multiply, I can say frequency, divided by charge of an electron 1.6 into 10 to the power minus 19 coulomb, clear. So we can say this is value of E. Now we know for different spectrum we have different value of nu, clear. So from here you can see in this table, clear. In this table actually you can see we have some part of a spectrum. Corresponding to that spectrum we have mean frequency. This mean frequency value we have constant. From here you can calculate energy of photon in terms of joule and energy from the formula that is given to you, clear. And after that actually I also write here the source from where these electromagnetic radiations are originating. Now let us try to understand this table. If we are talking about gamma rays, for gamma rays actually gamma ray is the origin, we can say whenever we are talking about nuclear physics. In nuclear physics you will find gamma rays. So origin is what? Nuclear origin. If we are talking about frequency, frequency is of the order of 3 into 10 to the power 20, 3 into 10 to the power 20 hertz. If we corresponding, if you find total energy of photon in terms of joule, we can say this is equal to h nu. Clear? H is equal to 6.6 into 10 to the power minus 34 multiply this frequency. Clear? For that one you will find answer 19.8 into 10 to the power minus 14 joule. Clear? Corresponding, if you divide this expression with 1.6 into 10 to the power minus 19, at the time you will find this answer 1.24 into 10 to the power 6 electron volt. Clear to everyone? Similarly, if we talk about X-ray, X-ray is actually originating from sudden retardation of high energy electrons. Clear? Mean frequency is given to you 3 into 10 to the power 18 hertz. Clear? Energy of photon, if we are talking about energy of photon, this is equal to 19.8 into 10 to the power minus 16. Clear? And if you again divide with charge of an electron, 1.6 into 10 to the power minus 19, this is equal to 1.24 into 10 to the power 4 electron volt. Clear? Now if we talk about ultraviolet, ultraviolet means we can say UV rays. Clear? For UV rays we have frequency 10 to the power 15 hertz, corresponding to energy, this is 6.6 into 10 to the power minus 19 joule, and if we divide with 1.6 into 10 to the power minus 19, you will find this expression 4.125. Clear? You can see from here 10 to the power minus 19, 10 to the power minus 19 cancelled out, 6.6 divided by 1.6, so this is equal to near about 4.1 something. Clear? And what is the source? Source of ultraviolet rays, this is excitation of atom. Clear? If we are talking about visible range, in visible range we can say the source is what? This is excitation of valence electron. Now we know that when the electron will jump, we can see, okay, we are talking about excitation of valence electron. Whenever we are talking about excitation of valence electron, the electromagnetic wave that is generated is of the order of visible range. Clear? Similarly, you can find the same thing for other we can say electromagnetic spectrum also. Let's suppose if I am talking about infrared. For infrared, source is excitation of atom and molecule. Clear? And microwave, we can say this is oscillating current in special vacuum tube. Clear? Actually, this infrared is important because this is related to thermal physics. Clear? Now, if we are talking about radio waves, if you are talking about radio waves is produced by oscillating current. Clear? So, like this you can actually utilize this table. Clear? So, this is all about this question. Now dear student, we are going to discuss this question number 8.10, and in this question it is given to you in a plane electromagnetic wave, the electric field oscillate at a frequency of 2 into 10 to the power 10 hertz and amplitude 48 volt per meter. What is the wavelength of wave? Clear? So, from here you can see, if I write number A, our objective in this question is to find wavelength. So, now we know V equal to f lambda, or you can say this is equal to nu lambda. Clear? Actually, if we are talking about vacuum, then we can say C is equal to mu lambda. Our objective is to find lambda, this is equal to C by nu, this is 3 into 10 to the power 8 divided by, what about frequency? Frequency is given 2 into 10 to the power 10 hertz. Clear? Yes or no? Yes. So, from here we can write like this, this is equal to 1.5 into 10 to the power minus 2 meter. Clear? So, this is value of wavelength. What is the amplitude of oscillating magnetic field? Amplitude means we can say maximum value of oscillating magnetic field. So, now we know one relation, C is given by E naught divided by B naught. So, from here we can write B naught, this is given E naught divided by C. Clear? What is value of E naught? E naught we can say maximum value of electric field is given 48 volt per meter. Clear? So, this is 48 divided by 3 into 10 to the power 8. So, from here we can say this is 16 multiply 10 to the power minus 8. Clear? This is what we can say 16 multiply 10 to the power minus 8, and this is Tesla. Clear? 16 into 10 to the power minus 8 Tesla. Now we can say, if we are talking about part number C, show that the average energy density of electric field equals the average energy density of magnetic field. Clear? So, now we can see how can we prove. So, actually if we are talking about average energy density means we can say energy density, clear, energy density of electric field is given by 1 by 2 epsilon naught into E square, clear. But we know in electromagnetic wave, electric field is oscillating in nature, clear. So when electric field is oscillating in nature, I can say here we will write not E, or we can say we will not write here this is E naught, we will write here E RMS, clear. So from here we can write like this, this is equal to 1 by 2 E naught, this is E RMS whole square, clear. Now can we write E RMS equal to in the terms of maximum value of electric field? Yes, this is equal to 1 by 2 epsilon naught, we can say this is E naught by root 2 and this is square, clear. From here you can say this is 1 by 2 epsilon naught E naught square divided by 2, clear. So from here we can say this is equal to 1 by 4 epsilon naught, this is E naught square, clear. Our objective is to in this question is to prove that average energy density, this is average energy density of this electric field is equal to average energy density of magnetic field, clear. So concentrate here. Now listen, so from here we can say average energy density of electric field, this is given by 1 by 4 epsilon naught into E naught square. Now we know there is a relation between maximum value of electric field and magnetic field, this is equal to 1 by 4 epsilon naught, this is equal to we can say E naught by B naught, this is equal to C, yes or no. So from here can we write like this, this is given by C times of B naught, clear, C times of B naught square, clear. So from here you can say this is 1 by 4 epsilon naught, yes, this is equal to what, C square, and we know one more relation C, this is given by 1 upon under root of mu naught epsilon naught, clear to you, this is again one relation. So we can say this is C square B naught square. Now we can put value of C we can say this is equal to mu naught epsilon naught and this is B naught square. From here you can say this one and this one cancelled out, clear, and this is equal to what, B naught square divided by 4 times of mu naught. This is what, this is average energy density of oscillating magnetic field, clear. So from here you can say that average energy density of electric field, this is equal to average energy density of magnetic field, clear to everyone, yes or no? Yes. So we can say this is all about this question, clear to everyone. Now dear student, we are going to discuss all the questions that is related to additional exercise. Now we are going to discuss question number 8.11, clear. In this question it is given to you, suppose that the electric field part of an electromagnetic wave in vacuum is given by E equal to 3.1 Newton per Coulomb cos of 1.8 y plus 5.4 into 10 to the power 6 t and I cap. Now we have to find what is the direction of propagation. First I am writing this expression of electric field, clear. So we can see value of E, it is given 3.1, this is maximum value of electric field, clear, 3.1 cos of 1.8 y plus 5.4 into 10 to the power 6, clear, and this is t, and we can see in the direction of I cap, clear. So from here you can see this electromagnetic wave is electric field is oscillating in x direction, clear to everyone. Now from here you can find number A part, what is the direction of wave propagation. So if we compare this equation with E equal to E naught cos of ky plus omega t, clear, E equal to E naught cos of ky omega t, and this is I cap. So this is in the direction x direction, clear. Now we can say whenever we find this positive term ky plus omega t, clear, it means we can say definitely this we can say electric field, or we can say if we are talking about direction of propagation of wave in the negative direction, but in which direction, because here we are getting term of y, it means I can say direction of propagation direction of propagation of wave, in negative y direction, negative y direction. Clear to everyone? Negative y direction. Now, if we discuss about part number B, in this question it is given what is wavelength. Clear? Now from here you can say this is k. If you compare, so value of k, this is equal to what? We know this is wave number 2 pi by lambda, and this is given 1.8. Clear? 1.8 in radian per meter. Clear? So from here we can find value of lambda. This is equal to 2 pi by 1.8. We can say this is 10. Clear? So this is 9. So lambda is given to you 10 pi by 9. Clear? 10 pi by 9. So from here you can say near about, if you take pi value 3.14, near about 3. So from here you can say approximately this is 3, and this value is near about 3.1 meter. Clear? Because this is 3.33, so but I am writing 3.1 meter. Clear? Now if we are discussing part number C, in part number C, what is frequency? Clear? For frequency, actually if you compare with this equation, we can say omega. Omega is given, this is 2 pi nu. Clear? And this is equal to what? 5.4 into 10 to the power 6. Clear? So from here we can write omega, we can say frequency. Frequency is given by 5.4 into 10 to the power 6 divided by 2 pi. Clear? 2 pi means we can say this is 6.28. So near about I am taking 6. Clear? So 4 divided by 10 into near about 6, clear, into 10 to the power 6. So from here we can say near about 9. Clear? Definitely this value come out to be less than 9. Clear? And we can say this is 10 to the power 5. Clear? So from here you can say frequency is given by, let's suppose 8.8 into 10 to the power 5 hertz. Clear? So this is all about frequency. Now our objective in this question is to calculate maximum value of magnetic field. Clear? So how can we calculate maximum value? Actually we know one relation between we can say speed of light, maximum value of electric field, and maximum value of magnetic field. Clear? So from there we can say this is part number D. C is given by E naught divided by B naught. Clear? So we can write like this, value of B naught, this is given by E naught divided by C. Clear? So value of B naught, this is equal to E naught. Maximum value of electric field, it is given in this question 3.1. So 3.1 divided by 3 into 10 to the power 8, and from here you can write like this, this is 1.03 into 10 to the power minus 8 Tesla. Clear? So this is maximum value of magnetic field. Clear? Now we have to write an expression for magnetic field part of a wave. Clear? So I am writing here. Clear? Now from here we can say, we can write like this, B equal to B naught, because the term of cos is given, so I am writing this is cos. Clear? So B equal to B naught cos of, clear, B equal to B naught cos of, now we can say this is given ky plus omega t. Clear? Now we can put values. So B naught is given to you 1.03 into 10 to the power minus 8 cos. Value of k we have, this is 1.8. So 1.8 y plus 5.4 into 10 to the power 6 t. Clear? You can write here unit also. Clear? Because in the given expression it is right here in terms of unit, you can also write. Clear? So this is all about this question. Clear to everyone? Now dear student, we are going to discuss question number 8.12. Clear? In this question it is given to you about 5% of power of 100 volt light bulb is converted to visible radiation. Clear? So actually power of a bulb, it is given to you 100 watt. Clear? And only 5% of this power is actually utilized. So I can say it is actually utilized means actually it is converted into radiation. Clear? Visual radiation. So power converted power into visible radiation, this is 5%. So we can say 100 divided by 100, and this is equal to only 5 watt. Clear? Now it is given what is average intensity of visible radiation. Clear? Our objective is to calculate average intensity. So actually we know intensity formula, we know this is power per unit area. clear, and because we are talking about a bulb, clear. So in bulb definitely light is actually spread out in equally in every direction, so we can say this area is to be spherical one, clear. So from here you can see we write here this is P converted divide by 4 pi r square, clear. Now if we discuss part number A, in this it is given we have to find intensity, average intensity at a distance of 1 meter from bulb, clear. So 1 meter means we can say I1, this is given by P converted, this is 5 divided by we can say 4 pi, clear, 4 pi, and what about r? So r is given, this is 1 square, clear. From here we can say this is 5 divided by 4 pi, clear. So from here you can say what is value of this is P, yes, and value is given 1 meter, clear, okay, fine. So from here you can write like this is 5 divided by 4 into 3.14, clear to everyone, 3.14. So now if you solve it, you will find this is 5 divided by near about we can say this is 12, so we can say this is 0.4 watt per meter square, clear. So this is average intensity in situation number A. Now if we are talking about part number B, in part B our objective is to calculate this average intensity at a distance of 10 meter. So we can write like this, I2, this is given by 5 divided by 4 pi, this is 10 square, clear. So we can write like this is 5 divided by 4 pi multiplied with 100, clear. So now you can say 5 divided by 4 pi, you have already solved, this is 0.4, so 0.4 divided by 100, so from here you can say this is 4 into 10 to the power minus 3, clear, 4 into 10 to the power minus 3, and this is watt per meter square, clear to everyone, 4 into 10 to the power minus 3 watt per meter square, clear. So this is all about this question, clear. Now dear student, we are going to discuss this question, and this question is 8.13, clear. In this question it is given to you, use the formula lambda mt equal to 0.29 centimeter Kelvin to obtain the characteristics temperature ranges for different parts of electromagnetic spectrum, clear. What do the number that you obtain tell you, clear. Now actually you know, if we are talking about Wien's law, actually this is related to Wien's law, and according to Wien's law we can say there is a relation between wavelength corresponding to we can say wavelength corresponding to maximum radiation and the temperature, that is what the product always remains constant, and this is equal to 0.29 centimeter Kelvin, clear. So from here we can say actually what is the particular information that we are getting, clear. Let's suppose for example if I am talking about a wavelength, this is 10 to the power minus 6 meter, clear. We can convert it into centimeter also, so we can say this is 10 to the power minus 4 centimeter, yes or no, 1 meter equal to 100 centimeter, 10 to the power minus 4 centimeter. So from here if we put this value here, so it is multiplied with T, this is equal to 0.29 centimeter Kelvin. So centimeter and centimeter we can say this is cancelled out, clear, and we can write like this, T value 0.29 divided by 10 to the power minus 4, or we can say 2900 Kelvin, clear. So from here we can say we can get a value of 2900 Kelvin. So actually what information we are getting, let's suppose if we want to find a wavelength of let's suppose if we want to find electromagnetic wave of a particular wavelength. So for that one, what is the temperature required, that we can find from this relation. It means if let's suppose if we know the range of wavelength for a particular electromagnetic spectrum, can we calculate temperature range for them? Yes. Let's suppose if we know the minimum, or we can say minimum and or we can say lowermost and the uppermost limit, at that time we can calculate value of temperature limits also, clear. It means we can get some idea if we provide this temperature range, at that particular temperature range we will find wavelength, we will find actually electromagnetic wave of a particular wavelength, clear. So now you can say this we can obtain from this result, clear, yes or no. So this is all about this question. Now we are going to discuss question number 8.14, and in this question it is given to you, given below are some famous numbers associated with electromagnetic radiations in different contexts in physics. Okay. State the part of electromagnetic spectrum to which each belongs. Okay, fine. Now if we are talking about part number A, in part number A it is 21 centimeter, clear. 21 centimeter means we can say actually this wavelength is very small, clear. And when we have wavelength, small wavelength, and we can say at the time this is related to radio wave, clear. This is related to radio wave. In radio wave you will find generally short wavelength and high frequency, clear. Short wavelength and high frequency, clear to everyone, clear? Yes. Now if we are talking about part number B, in part number B you can see 1057 megahertz, again a very high frequency we have, and frequency of radiation arising from two close energy levels in hydrogen atom known as lamp shift, clear. Again this is related to radio wave, clear, radio wave, clear. Now if I am talking about part number C, it is given in this question 2.7 Kelvin. This temperature associated with isotropic radiation filling all space through a relic of Big Bang origin of the universe. Actually we do not need any information from this one, but our objective in this question is to calculate wavelength part, clear. So how can we calculate wavelength? So from here you can see, actually we know one relation lambda mt, this should be constant, yes or no, and this constant we know this value we have 0.29 centimeter Kelvin, clear to everyone. In this question it is given this is 2.7 Kelvin. So from here you can see lambda m, this is given by 0.29 centimeter Kelvin divided by 2.7 Kelvin. So Kelvin and Kelvin cancelled out. So from here we can say 29 divided by we can say 27, and it is divided by 10. So from here if you calculate near about you will find 0.11 centimeter, clear. So 0.11 centimeter, this wavelength actually lies in the range of microwave, clear. So we can say electromagnetic spectrum, this is related to this wavelength, that is microwave, clear. Now if we are talking about part number D, directly you can say this is 5890 angstrom and 5896 angstrom, double line of sodium. So actually this is we can say related to visible spectrum, because range of visible spectrum is what, 4000 angstrom, clear. If we talk about 4000 angstrom to we can see 7500 angstrom, this is according to NCERT, clear. 4000 angstrom to 7500 angstrom, clear. So we can say definitely we can say this part D, this is related to visible spectrum, clear. This is related to microwave, clear. Now we are going to discuss last part. In last part it is given 14.4 kilo electron volt energy, it is given to you. Now we have to find that this is related to which part of electromagnetic spectrum, clear. Energy of a particular transition in 57 nucleus associated with the famous high resolution spectroscopic method, okay, fine. So from here you can say energy part is given 14.4 kilo electron volt. So 14.4 kilo electron volt, this is energy. So E equal to we know this is h nu, clear. This is 14.4 into 10 to the power 3 into, because this energy is given in electron volt, we can convert into joule if you multiply it with 1.6 into 10 to the power minus 19 joule, clear. So now we can see our objective in this question is to calculate first value of nu. So 14.4 into 1.6 into 10 to the power minus 13 divided by value of h, this is Planck constant, so 6.636 into 10 to the power minus 34, clear. So near about we can say near about this is cancelled out, clear. If you take this one, this is 10 to the power 34, we can say this is 21, yes or no, this is 21, so this is 21, clear. So from here we can write like this, this is 14.4 into we can say 10 to the power 6 or into 10 to the power we can say 15, we can write like this, clear. So from here you can say this is 14.4 mega and into 10 to the power 15 hertz, clear. So we can say actually this is a very high frequency, and but this frequency range it lies for X-rays, clear. So now we can say electromagnetic spectrum that is related to this range, this is X-ray, clear. So this is all about this question, clear. Now dear student, we are going to discuss this question number 8.15, and in this question it is given to you, answer the following question, okay. Number A part, long distance radio broadcast use short wave bands, why? Actually if we talk about long distance radio broadcast, so actually they utilize short wavelength because they are actually we can say they are reflected back by ionosphere in our atmosphere, clear. So correct answer or very simple answer we have, long distance radio broadcast use short wave bands because they are reflected by ionosphere, clear. So directly we can say this is reflected by ionosphere, clear to you. Second part, it is necessary to use satellite for a long distance TV transmission, why? Yes, because if we are talking about long distance TV transmission, we can see actually if we are actually giving that of we can say this transmission, it means if we are giving this electromagnetic wave in our atmosphere, this electromagnetic wave is actually not reflected by ionosphere, clear. That's why we need an artificial satellite to reflect that signals, clear. So this is clear to you, clear. A very simple answer we have, actually this whatever the electromagnetic wave that is emitted for TV transmission, it is not reflected by ionosphere, so we need an artificial satellite, and that's why we use this one, clear. Now if we are talking about part C, optical and radio telescope are built on the ground, but X-ray test astronomy is possible only from satellite, why? Actually if we are talking about radio and optical telescope, the wavelength range we can say their wavelength is less, very small, or we can say they can easily penetrate in the ionosphere, clear, in our atmosphere. But what about X-ray? So we can say actually X-ray radiation is absorbed by our atmosphere, clear, and we can say so that their range is actually restricted. That's why we are actually utilizing this X-ray astronomy only from satellite, clear. So actually we set up all the things on a satellite, and from where we are actually utilizing X-ray astronomy, clear. Now if we are talking about part D, in part D it is given the small ozone layer on the top of stratosphere is crucial for human survival. Yes, you know very well from junior classes, you have been teaching this term, that actually ozone layer prevents us from the harmful UV radiation that is coming from sun, clear. That's why we that's why this is required for the survival of human, clear. If let's suppose if we do not have ozone layer, at that time it may causes some type of skin problems as well as some types of other diseases also, clear. Now if we are talking about part number E, clear, in part number E it is given, if the earth did not have an atmosphere, clear, would its average surface temperature be higher or lower than what is now, clear. So just imagine this situation, if the earth did not have an atmosphere. So when earth did not have any atmosphere means we do not have any greenhouse effect, and actually due to this greenhouse effect the temperature of our atmosphere it will maintain, clear. So let's suppose if there is no atmosphere, we can see there is the radiation that is coming from earth, surface of earth, that is not absorbed by any particle. So directly we can see when all the heat is actually going outside of the earth, at the time definitely we feel here winters, clear. So definitely the temperature it becomes lower than what is now, clear. Now if I am talking about part number F, some scientists have predicted that a global nuclear war on the earth would be followed by a severe nuclear winter with a devastating effect on life on the earth. What might be the basis of this prediction, clear. So actually this is predicted that let's suppose if there is a nuclear world war happen, at the time all the we can say actually whenever we are utilizing nuclear weapon, at the time the clouds that is formed by all the nuclear particles are surround, it will actually completely surround Earth, clear. So we can say in maximum part of Earth there is no incoming of solar radiation. So whenever the solar radiation will not come, we cannot maintain a particular temperature on our Earth, and definitely it is followed by nuclear winters, clear. So this is statement that is given by scientists, clear. So this is all about this question, clear to everyone. So dear students, this is all about class 12 chapter number 8 electromagnetic wave and all NCERT and exercise solutions, clear. So hope you enjoyed this session, and again try to revise all these questions again and again, and definitely you will get benefited from this session, clear. So this is all about this session. Thank you so much.